Welcome and thank you for joining me today as we talk about how to calculate average atomic mass and percent abundance. Um, so we're going to get started here with just a practice question. So I have uranium has 3 common isotopes. The abundance of uranium-234 is 0.01%, the abundance of uranium-235 is 0.71%, and the abundance of 238 is 99.28%. What is the average atomic mass of uranium? So if you think back, we've talked a little bit about average atomic mass is a weighted average. So average atomic mass equals our mass times our percent. So I'm going to say mass 1 times percent 1 plus mass 2 times percent 2, and so on and so forth until you're done. So in this case, we have three isotopes. We're going to do at least 3 of these. We're going to do 3 of these. And so here we're going to have our, I'm going to call it the AAM, equals our first mass times our first percentage. And we have to make our percentages a decimal. This is where we need to be careful. Or you can do it all at the end, that's fine too. But I'm going to have mass 1 is 234 AMU times, this as a decimal is going to be 0. Remember, to make it a decimal, you got to go to the left. So 1, 2. So I need 1, 2, 3 zeros and a 1. Plus 235 AMU times 0.0071. Plus my last one is 238 AMU times 0.2 to the left is going to be 9928. If I multiply and add all those together, I should get an answer. So my average atomic mass should equal 237.98 according to my calculations. And my unit's going to be AMU, because we have AMU plus AMU plus AMU gives me AMU at the end. Make sure you include your units on this. This is how you do average atomic mass. I have a practice question on the next slide that you can try on your own. If you bring your work into me, I can tell you if you got it right or wrong, because I have not posted an answer for that one. But here's one that you can try. Titanium has 5 isotopes. Titanium-46 is at 8%, titanium-47 is 7.8%, titanium-48 is 73.4%, titanium-49 is 5.5%, and titanium-50 is 5.3%. Calculate the average atomic mass of titanium. So try that as practice, and then you can bring your work into me, show me, and I'll look through it and make sure we're on the same page. Okay, this is going to be looking at, this slide is going to be percent abundance. So if you understand average atomic mass and want a challenge, this is for you. So in this case, we'll read the question and we'll talk. Naturally occurring elemental iron has an average atomic mass of 55.847 AMU. I want to calculate the percent abundance of this element's isotopes. Iron-55, which has a mass of 54.81 AMU, and iron-56, which has a mass of 55.97 AMU. So things that I know. 1, my equation is going to stay the same. Average atomic mass is still equal to mass 1 times percent 1 plus mass 2, that's a 2, times percent 2. But in this case, I've given you the average atomic mass. You don't have either percentage, so we have 2 of these. So we're going to set this up first. So we have 55.847 AMU equals mass 1, 54.81 AMU, and I'm going to put that times, I don't know what it's multiplied by, so I'm going to call it X, plus 55.97 AMU times a different variable that's not necessarily the same, so we're going to call this one Y. Okay, so now I have my equation set, but I have 2 variables. If I have 2 variables, that means I need 2 equations. Okay, so where do I get my second equation from? Well, these are percentages. So think to yourself, what's the best you can do on a test? What is the absolute best you can do on a test? And if you think correctly, if you're thinking about this, the best you can do is 100%. So because these are percentages, I know that x plus y has to equal all of it. Correct plus wrong has to equal 100%. And 100% made a decimal is going to be 1. So if I know x plus y equals 1 and I have this laid out up above, I can then substitute and we can get down to one variable. So in this case, let's solve for y. So I'm going to solve this equation for y. So I'm going to subtract x on both sides. So I end up with y equals 1 minus x. Okay, now I'm going to plug this in for this y. So my new equation is going to look like this. 55.847, I'm going to leave off the units, but they're still there, equals 54.81 times x plus 55.97 times 1 minus x. And then I'm going to solve. So now I have 55.847 equals 54.81x plus 55.97 minus 55.97x. And we're going to combine all our like terms. So if I take 54.81 minus 55.97, I should come to an answer of negative 1.16. X on this side. And then if I take my 55.847 minus 55.97, on the other side I should get negative 0.123. So here's where I'm at this point. Now I can divide both sides by negative 1.16, and I end up with x equals x should equal 10.60 0.10, sorry, let's do this correctly, 0.1060. But we said x has to, so this is going to be my x. And now if I make this a percentage, I know that that is equal to 10.6%. And x was associated with iron 55. So I have 10.60% Fe55. If I'm confident with this answer, I can then use my 1 minus. So I can take 1 minus 0.1060, and that should give me 0.894, which I'll make a decimal or make a percentage. So this will be 89.4% Y, which was iron 56. So these would be my two answers on this one. And this is percent abundance. So if you're struggling with average atomic mass, don't worry about this. If you're comfortable with that and want to try something new, try this out. Here's a practice question for you. Again, I don't have the answer on the next one, but on this one. But if you work this through, or work and get stuck, come see me. I can help you kind of work your way through to the end. But thank you for working with me through this. I hope that things are going well. If you have questions, stop in and see me, and we will continue on.